Okay. The most common mistake I saw was people had the inverse and the converse backwards. They just plain forgot which one was which. So obviously you have to have that memorized. Now, when we talk about inverse, is that the one where we reverse the hypothesis and conclusion? Or is that the one where we just negate? Which one is which? Inverse, is that the negate or the switch? Inverse is the one where we just negate. The converse is the one where we switch the hypothesis and conclusion. Okay? A few people struggled with all students like school, and just converting that into a conditional gave some people trouble. So let's get that out of the way. What would be a good way of writing all students like school as an if-then statement? Derek, go ahead, jump in there.
If you're a student, then you like school.
Yeah, the most common way we were doing this in class before, we would say things like, if you are a student, then you like school. All right. Okay, so that's what we were looking for in terms of a conditional. Now, as far as the symbols, you were supposed to write like this. Okay, which would be read if P then Q, but that's what I meant for the symbols of the conditional. Okay, most people got that right. Now, as far as the inverse, that's where, first of all, let's do the symbols first. The symbols sort of remind you what to do. Not P implies not Q. Okay? That tells us that this is the one that we're just negating everything. All right? So, how would I say this in words? Help me out, you guys.
If you are not a student, then you don't like school.
If you are not a student, then you do not like school. Okay, so something like that for the inverse is what we're looking for. The converse, that's the one where we decided. What will be the symbols for the converse, you guys? Blurt it out.
If you like school,
Just give me the symbol first.
If Q, then P.
Right, if Q, then P, because this is the one where we switch it up. Okay, and Devon was saying, if you like school, then you are a student. Okay? And finally, the contrapositive. That's the one where we negate it and reverse it. So the symbols for that would be, if not Q, then not P. Okay? So that's what the symbols should look like. So the contrapositive is going to be similar to what I just wrote for the converse, only with the word not in there. Or so, instead of saying if you like school, I'm going to say if you don't like school. Then you are not a student. Okay, any questions on that first part of the quiz? All right, you can pretty much guarantee that all of this stuff is definitely going to be on the test on Friday. So if you missed any part of this, let's make sure we have it down 100% so you won't make the same mistake on Friday. All right, let's move on. What else do I got here? Use the following biconditional statement. Okay? We know that a biconditional involves this if and only if. So this is a biconditional. Now we're supposed to take this and turn it into an if-then statement. So look, here I have my hypothesis. The shape is a pentagon. And here's my conclusion. A shape is a polygon. Okay, so my conditional would be something like this. If a shape is a pentagon, or I would have accepted it if you said if it is a pentagon, but I'm going to say it formally. If a shape is a pentagon, then it is a polygon. Okay, so that's what we were looking for the conditional. Now, is this true or false, you guys? Yeah, this is definitely true. Okay, a pentagon is a kind of polygon. So if a shape is a pentagon, then yeah, it's automatically a polygon. That's definitely true. Okay, now the converse. How do I form the converse of this? Right, this is the one where we just reverse the hypothesis and conclusion. So if a shape is a polygon, then it is a pentagon. All right? Is this a true statement or a false statement? Only heard one person. Is this true or false, you guys? This is false. Okay? We have all kinds of polygons. You know, triangle, quadrilateral, hexagon, heptagon. Chase, head up, brother. So, if a shape is a polygon, it could be any of those. So that doesn't mean it's a pentagon. So that's definitely false. Derek.
Alright, so I know for the biconditional to be true, like both the converse and inverse have.
Okay, hear me on this. This is how you know if a biconditional is true or false. Do not get into the trap of just trying to just listen to it and try to just figure out if it feels true to you or not. Because your brain is not used to thinking in two directions at once. Okay? A biconditional means, by definition, the original statement is true and the converse is true. That's what it means for a biconditional to be true. So, if the original statement is true and the converse is true, then the biconditional is true. If the original statement is false or if the converse is false, then the biconditional is false, by definition. Okay? So, when I asked you, is the biconditional true or false, all you were supposed to do is look above. You see the conditional, true. You see the converse, false. So is the biconditional true or false then, guys? I need to hear everybody. Is the biconditional true or false? False. It's false. Okay? Haven, how do I know if the biconditional is true or false in general? What does it take for a biconditional to be true? And what else? Two things have to be true. The converse and the conditional, the original statement. Both things have to be true. If one of those is false, it is false. So we would say the biconditional is false. Why? Because the converse is false. Okay? Syllogism. If someone knocks on the door, then the dogs will bark. If the dogs bark, then John gets a headache. Okay? You see that middle part that's repeated. The dogs will bark if the dogs bark. So we know for syllogism we're trying to get from A to C. So basically if you cross out that middle part, then that's going to give you your syllogism statement. So everybody put something like, if someone knocks on the door, then John gets a headache. Alright, forgive my sloppy handwriting. I'm trying to write fast. People are already falling asleep. But I have to go over this quiz so I can patch any holes. There's no way around this. So I apologize for droning on, but this is a necessary. It has to be done. Okay. Now number 7. There were some issues with number 7. When it comes time for detachment, one thing I tried to emphasize to you guys was, on the one hand, syllogism. The result of syllogism was a whole if-then statement. Okay? But when you do detachment, the result of a detachment is just a single conclusion. That's it. Okay? Remember, for syllogism, we did the A, B, C thing? Basically, for detachment, it was sort of like this. You had if A, then B. Okay? And then you were given an A. And then you were asked for a conclusion. Okay? And your conclusion was going to be of the form something similar to B. Something similar to B was going to be your conclusion. Okay? So here's the key. Let me color coordinate this for you a little bit. If the lines are perpendicular, that's like A. Then they intersect to form a right angle. That's like B. Then they gave us some additional information. Line L is perpendicular to line M. That's A again. The conclusion that we were looking for should have been of the form B. Okay? We were looking for a statement that's similar to B. So basically, anybody that said, if you mention the word perpendicular on this line, then you got it wrong. Okay? The conclusion of a detachment should just be that last statement, the B part, the part that I have here in blue. You should have said something about intersecting to form a right angle. Nothing else. Nothing from the yellow should have been included on that line. And it certainly should not have been a whole if-then statement. Okay? So what I was looking for was basically this. Let's see. Line L is perpendicular to line M. So therefore, line L and M intersect to form a right angle. Okay? L and M intersect to form a right angle. Okay? That is what you should have put for your conclusion for detachment. Jet. All right, for number 8. Most people got number 8 right. Okay? Sally measured all but one angle of a hexagon. The total degrees for the angle she measured was 600. What's the measure of the remaining? Okay, hexagon. How many sides is that? That's thing number 1. Hexagon, it's a 6-sided shape. As soon as you see that word hexagon, the first thing you should have been thinking was, well, wait a minute. What's the total? If he says hexagon, I should be able to figure out the total. Derek, how do I find the total, my friend?
You do 6 minus 2 times 180.
Yeah, we do 6 minus 2 times 180. Okay, what is that total, my friends? 720. 720. Okay, so that tells us we have a total of 720 degrees. Of that 720 degrees, not yet, Bryant. When it gets toward the end, you just be still. She has found 600 degrees so far. So if we just simply subtract that 600 degrees, that should leave what's left. How much was left, you guys? 120. Okay? So that's why the answer to that one should have been B.